Okay, so next I want to talk about the tubular function tests. So how do we assess tubular function? And so the first test that we can that's often used, and the sort of most basic one, is urine sodium. Oops. And some assumptions that we make here. So first of all, urine sodium is only relevant in the context of hypovolemia. So if we have low volume, so hypovolemia, then our urine sodium can give us a sense of tubular function, right? Because remember, in the context of hypovolemia, what should be happening? Our body should be turning on the RAS system. We should be trying to hold on to sodium by a variety of mechanisms throughout the tubule. And so our urine sodium should theoretically be very low. So if in the context of hypovolemia, if urine sodium is low, then, if urine sodium is high, that kind of indicates a problem. That indicates tubular dysfunction, or something's going on. But the issue with this is, urine sodium is tough, right? Because if we don't have hypovolemia, or say we're producing kind of dilute urine, or, our for whatever reason, we're actually getting a high volume through the tubule, that could dilute our urine sodium and make it look normal. But because, if you think about urine sodium is going to be not only how much sodium we're getting rid of, but also the amount that's kind of diluting it. And so it's going to be related to our GFR. So it's actually better to use, in order to kind of create some sort of standard baseline, it's better to utilize the FeNA, or the fraction excreted of Na. That is a better marker for tubular dysfunction. And the reason for that is because basically it allows us to mark our sodium against the creatinine clearance. So basically the way that we calculate FeNA, there's kind of this complicated formula that I feel like, is multiplication of different, quantities. The way that I like to think about FeNA is it's the clearance of sodium divided by the clearance of creatinine. And so remember, the clearance of creatinine is going to be equal to our GFR, right? So the clearance of creatinine is going to be the GFR. And so basically we're metricing our sodium clearance against the GFR, right? So clearance of sodium against clearance of, so this is effectively sodium clearance, Na clearance, over GFR. And so this, we can use clearance of sodium over clearance of creatinine in order to estimate that quantity. And so what this is going to look like is, since clearance of sodium, remember, is urinary sodium times volume of urine divided by plasma sodium, and we divide that now by urine creatinine times volume of urine over plasma creatinine. If we kind of cancel all these things out, then we get that sort of that equation that you might recognize, UNA times PCR over UCR times PNA. It's nothing but taking the clearance of sodium and dividing it by the clearance of creatinine. And so now let's think about what this means. If our, in the extremes, so suppose our clearance of sodium is 0. We're not clearing any sodium. What does that mean? That means that, all the sodium that's coming into the into the filtrate is being reabsorbed, right? So if FeNA is equal to 0, then our clearance of sodium is equal to 0, right? So Na clearance equals 0, and this indicates full sodium reabsorption. If FeNA is equal to 1, what does that mean? That means that our sodium clearance is equal to the clearance of creatinine. So that would mean that whatever is coming in through the filtrate, that is simply getting dumped out. So that would indicate no reabsorption. And you know, if FeNA was greater than 1, that would indicate some secretion, but you know, that doesn't happen to sodium. So the key here is that, you know, between 0 and 1, we get kind of an understanding of how much sodium is being reabsorbed. And remember, sodium reabsorption is kind of a critical function of our tubule. So if our sodium, you know, remember this, so FeNA is equal to 1 indicates no reabsorption. And so, you know, this is why FeNA is a good metric for tubular dysfunction, because it tells us, you know, if FeNA is closer to 0, that means that our tubule is working pretty well. Remember, this is still all in the context of hypovolemia. So this, you know, we're still in hypovolemia here. But if FeNA is closer to 1, or if it's greater than something like, you know, a couple of percent, then we should be worried, because basically what that means is that we're getting poor reabsorption and